Monsieur there. Anti-aging.
Thank you very much for having me. And I will be talking about the subject that I think is going to be the science of tomorrow, signaling energy and how it revolutionizes anti-aging. And signaling energy offers an anti-inflammatory technology that can be used for rejuvenation and for lipolysis. Now, trauma leads to inflammation, and chronic low-grade inflammation underlies a unified field of aging and disease. So although lasers, radiofrequency, and other techniques are often claiming that they are that they don't cause inflammation, or that they even improve inflammation, however, there are controlled studies, experimental studies that show that node-like proteins that include NOD1, NOD2, and NLAP3 and IE, which are the sensors of the immune danger signals during inflammation, as well as the C-reactive protein in the blood, seem to increase after laser treatments. And traumatic procedures also have to do with free radicals that are increasing. Free radicals, Nagai offered the first direct observation of unstable free radicals that are generated by laser performed by EPR at 100K. 2012 research by a number of investigators has concluded that radiofrequency induces biochemical changes by increasing free radical attacks to structural biomolecules such as DNA and lipids. And this is a number of researchers that have postulated that in laser treatment increases inflammation. These are the researchers that state an increase of inflammation after radiofrequency. We do have a necessity for non-traumatic technologies. We can increase fibroblast secretion of collagen without trauma by utilizing different signals. And Lossinger et al. Since 1999, and after that other investigators, including Yang et al. In 2004, found a significantly higher production of collagen at very specific frequencies. What signaling technology is, it started with neurophysiology research in natural frequencies that are produced by certain parts of the brain. In cardiology, the pacemaker, that's signaling technology. The pacemaker replaces signals of the pacemaker cells. In brain research, external frequencies were built to stimulate and reinstate natural frequencies through the process of resonance. What resonance does, it basically amplifies two frequencies together, it makes them much bigger, so the gestalt is bigger or more than the sum of the parts. Every function in the body is the result of a signal, otherwise we would end up with masses of collagen one day and the next day nothing, and we would end up with all kinds of tumors all over our bodies. The body stops that. The body knows how to produce the amount that is necessary, and the reason why that is because there are signals to give that direction. So signals control the production of every element in the body. And what signaling technology does, it basically fills in the gaps or amplifies these signals that have deteriorated due to disease or aging. This is a slide I can give you of how cells integrate multiple signals, and here we're introducing the concept of signaling pathways, which is integrated signals. And imagine that basically like a sentence, if you like, or a phrase that is composed from different letters. So it's a universal language that our bodies talk, but nobody can read. It's not a language that anybody can speak. It's not a dead language. It's not a language. It's just something that has always been inside us, and yet we don't know it. It's a new language. Now, this is an example of how this language works. And this is the lettering for an insulin code. And as you can see, it starts with the ATG, and the sequences and with AGG, that means end. ATG is the beginning, AGG is the ending, and TAG is again a different sequence. So all these sequences, imagine how if you kind of lost one of those letters from the sequence, or more than one letters, then this signal would start either changing or being incomprehensible and therefore useless. So what the technology does, it basically fills in signals, like the letters that are missing, but it does it through waves. The way the speech is waves, this technology is also waves. So we investigated how such signaling pathways are organized, and what we think is that it's relevant not only for understanding how normal cells work, but also for appreciating the molecular basis of aging and disease.